Welcome to PreMath. In this video, we have got this blue square ABCD that consists of these two identical trapezoids and this isosceles triangle, as you can see in this given diagram, such that these three segment lengths AF, BF, and EF are equal in length. And these are our 90-degree angles. And furthermore, the area of this blue square has been given to us as 64 square units. And now our task is to calculate the area of this green shaded region, this area and this area combined. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started, and here's our very first step. Let's focus once again on this blue square ABCD. Its area has been given to us as 64 square units. So therefore we could easily calculate the side length of this blue square. And now let's recall the area of a square formula. Area is always equal to s square, where s represents the side length of the square. And in our case, the area has been given to us as 64. So therefore we could write s square is going to be equal to 64. And now I am going to undo this square by taking square root on both sides. So therefore we could see the side length s of this blue square is going to be positive 8 units. So therefore this side length is going to be 8 units, and since all these side lengths of the square are equal, so therefore this side length is going to be 8, 8 and 8 across the board. And now since we are interested in calculating the area of this green shaded region, and now let's make an observation. We can see that this green shaded region area is going to be equal to the area of this big blue square minus the area of this white trapezoid. We are talking about this white trapezoid area. So therefore now our task is to calculate the area of this white trapezoid. And furthermore, we know the area of the blue square has been given to us as 64 square units. And here's our next step. We know all these three segments are equal in length. If I label this length as lowercase a, then this length is going to be lowercase a and lowercase a as well. And now we are going to focus on this triangle ABF. And we could see that this is our isosceles triangle, since this side length equal to this side length. And now in this next step, I have dropped this perpendicular FP on this base AB by just extending this EF all the way to this point P. And since this triangle ABF is an isosceles triangle, so therefore this perpendicular is going to divide this base AB into two equal parts. In other words, AP length is going to be equal to this BP length, and we know all this whole length is 8. So therefore this AP length has got to be 4 units, and likewise BP length is 4 units as well. And now we are going to focus on this right triangle FBP. We know this whole length is 8 units, and this segment length is lowercase a. So therefore this FP segment length has got to be 8 minus a. And now we are going to apply the Pythagorean theorem on this triangle FBP. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is lowercase a, whereas our two other legs are 8 minus a and 4. Let's go ahead and fill in the blanks in this Pythagorean formula. So we got 8 minus a whole square plus 4 square equals to a square. And now let's recall this famous identity. A minus b whole square could be written as a square minus 2ab plus b square. We are going to apply it on this binomial on the left hand side of this equation. So therefore this is going to become 64 minus 16 times a plus a square plus 16 equals to a square. And now we can see a square and a square, they are gone. And now we are going to combine these like terms. So therefore we could write 80 minus 16 times a equal to 0. And now I'm going to move this 16a on the other side. So therefore we got 16 times a equals to 80. And now I'm going to divide both sides by 16 to isolate lowercase a. So therefore our lowercase a value simply turns out to be positive 5 units. So thus our this lowercase a value simply turns out to be 5. And furthermore we know that this segment AC length is going to be equal to this segment BP length. So this is going to be 4 units. And now we are going to calculate the area of this trapezoid. And now let's recall the area of a trapezoid formula. Area is always equal to the height h times the sum of these bases a and b all over 2. And here our base a is 5 units, base b is 8, and our height h is 4. So therefore the area of this trapezoid is going to be 4 divided by 2 times 5 plus 8. And here we can see this reduces to 2, and that's going to give us 13. So therefore we could write 2 times 13, and that is going to be equal to 26 square units. So thus the area of this white trapezoid turns out to be 26. And here's our final step. Now we are going to calculate the area of this green shaded region. We know the area of the blue square has been given to us as 64, and the trapezoid area we already figured out as 26. Let's go ahead and fill in the blanks. So we got 64 minus 26 is going to give us 38 square units, the area of this green shaded region. So thus after all the calculations and manipulations, the area of the green shaded region turns out to be 38 square units. In other words, the area of this green shaded region is going to be 38 square units. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.